Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's webinar by WaterPhilippines. Waste to Resource, Wastewater Treatment and Reuse for Business Profitability. Brought to you by Biopipe Global and supported by the Philippine Waterways Association. Before we officially begin, please take note of the following reminders. All microphones and videos of the attendees will be automatically muted. The chat box will be disabled throughout the session. If you have any questions to our speakers, please type it on the Q&A box, which you can see at the top or at the bottom part of your screen, depending on which device you are using. We'll select a few questions that our speakers could answer during the Q&A session. Should there be any internet disruption during the session, please be patient and try to sign in again. You may also watch us through our live stream on Facebook. Just search for Water Philippines Expo. To get a copy of the slides, later at the end of the webinar, we will ask you to answer a survey form that will enable you to download the presentations. Today's webinar will be moderated by none other than Engineer Rico Oncoy. He has extensive experience in the field of civil, sanitary, and environmental engineer professions. Engineer Oncoy is currently an environmental engineer consultant at the Arcan Technologies Incorporated, a wholly owned subsidiary of San Miguel Corporation. He is an international member of the Water Environment Federation in the United States, a former president, a former National Council chairman, and a fellow at the Water Environment Association of the Philippines. He is also a former national vice president and a fellow at the Philippine Society of Sanitary Engineers and a member of the Philippine Institute of Civil Engineers. Currently, he is a director and the chair of the Technical Committee of the Philippine Waterworks Association. Ladies and gentlemen, it is our pleasure to have here with us today Engineer Rico Oncoy.
Thank you for the kind introduction, and thank you to those who have tuned in today's webinar. Brought to you by Biopipe Global, hosted by Water Philippines, and supported by the Philippine Waterworks Association. Today's webinar will focus on the Philippine market and the methods and benefits to reusing treated wastewater for both businesses and water districts. Although the Philippines is surrounded by many kilometers of coastal waters and is abundant in rainfall, there is still a growing problem in clean water supply. Overpumping of groundwater and poor sanitation enforcement has caused freshwater and oceans to become contaminated. In cities like Cebu, overpumping of the groundwater has even caused the water supply to become infiltrated with seawater. The DNR Administrative Order 2016-08 regulation seeks to alleviate these problems with new and strict standards to water discharge. However, there still does not solve the issue on securing the nation's water supply. For a growing population, instead of thinking of this as a problem, companies and nations around the world have thought of how to make wastewater into a valuable resource. We're actually glad to have Biopipe with us today. They have operations worldwide with a focus on alleviating water stress through an innovative on-site wastewater and water recycling plant that produces no sludge, odor, or noise. And I am excited to hear later about the works that they have done around the world. We have assembled industry leaders from the Department of Environment and Natural Resources, the private sector, and the global community to speak on methods, technologies, and policies that can give a pathway to using wastewater as a resource. Without further ado, let's start the session with our first speaker. Our first speaker graduated from UP Law in 1990 and practiced environment and public health law since then. She went on a fellowship on culture and ecology at the University of California, Berkeley, and received the 10 Outstanding Young Men Award in 2004. She has developed local consensus and protected area policies, assisted in crafting numerous public health and policies, and consulted for the Global Environment Facility, United Nations Development Program, the Asia Foundation, Resources and Economics Foundation of the Philippines, and government entities such as the Philippine Institute for Development Studies and the Biodiversity Management Bureau. She has designated, she was designated as Undersecretary of the Department of Environment and Natural Resources in 2016, and later Regional Executive Director at the Calabar Zone region until June of 2019. She is currently dated to the Office of Deputy Speaker, Loren Legarda, to work on the department's legislative agenda. Please give a warm virtual welcome to Ms. Ipat Luna.
Thank you, Engineer Ongkoy. Um, I'm very glad to be here, and I'm very interested in waste to resource measures and innovative methodologies. Um, I think the slides will be operated from Al, if that can be started, please. Um, well, my presentation dwells on the price of inaction, bearing the cost of lack of wastewater treatment and sewerage infrastructure. Not only are we losing the resource that we would have gained from wastewater that's treated, but the longer we delay, the more expensive it is. Disclaimer, any views expressed here is not that of the DNR or Deputy Speaker Legarda. These are from my own studies and investigations into the issue of wastewater. Next slide, please. The case, which was filed by concerned citizens against MMDA and other agencies, requires the agencies, there's about 13 agencies that were respondents in that case, to make Manila Bay swimmable. And that was a decision that was handed out by the Supreme Court in 2011 still. Next slide, please. Because of that decision, the DNR, as head agency of the multiple agencies in the case, came up with the operational plan for the Manila Bay Coastal Strategy, or OPMBCS. The dates are 2017 to 2022. There are 5-year batches of this. This is already in the third batch, third sector, I guess. And the goal is still rehabilitated, preserved, and waters restored and maintained at SB level, which is Class B is swimmable. The targets are liquid waste management, solid waste management, informal settler families, habitat and resource management, and institutional arrangements. Next, please. This is just a, next slide, please. This is just a quick view of everything that is in that plan. Unfortunately, there isn't all that much budget for enforcing this plan. Hence, there's 80 million in the DNR, and many other agencies have their own too, but it is not enough to meet the objectives of the Supreme Court mandate. Next, please. Next slide, please. Yes. In August last year, the Supreme Court had another opportunity to issue a decision on the case of pollution of Manila Bay against the concessionaires, which was filed by the department. In the decision, it reiterated that water is a public trust, and that from the finality of the decision, petitioners should have paid fully the amounts for pollution that are levied against the concessionaires operating the water provision of Metro Manila and nearby provinces. And it also further enjoins that not only the petitioners, but all water supply and sewage facilities and or concessionaires in other highly urbanized cities have to strictly comply with Section 8, which says that there should be full coverage of sewerage infrastructure in these highly urbanized cities. Next, please. Just this year, through a foreign-assisted project, the NEDA came up with the Manila Bay Sustainable Development Master Plan. This was released, I think, in January, and reiterations until August this year, with a vision for a sustainable and resilient Manila Bay. This is on top of the OPMBCS, and it required more in-depth studies, analysis, consultations, etc. And these are the characteristics of the vision: protection of Manila Bay, equitable improvement in quality of life, communities with access to safe, affordable, and formal housing, water quality suitable for its intended beneficial use, and a safe, resilient, and adaptive Manila Bay. Next, please. Next slide, please. There is a requirement for acting above and beyond all of these plans. Government response will always be limited to the scope of agency mandates and resources. And because of its motivational meaning, the mandate has to be looked at in terms of what it means to the agency itself. For example, the Department of Public Works and Highways considers roads and bridges their primary public works. And they have very little in terms of sewerage development, sewerage infrastructure development themselves. But multiple sectors have a stake in a more productive and living Manila Bay. This crisis can be turned into an opportunity. Partners can discover solutions, and counterparts in other regions can, the crisis can be averted in other water bodies. Resources can be mobilized to address seemingly intractable problems in innovative and enterprising ways. We can have rapid and visible solutions, adaptive and cooperative solutions. Next, please. And of course, the most adaptive one will be to use the treated water as a resource. And as you know, currently we are, the government is building a dam in one of our mountains, and it's facing opposition from some sectors. And it would be wise to look at how much water can be generated for even just industrial or cleaning purposes, not potable, to generate enough so that we will be able to cut the requirement that the dam is supposed to respond to. So we need to mobilize multiple sectors. We need government, business, civil society, communities, and nothing less than a cultural shift, an enterprise for motivation. And there needs to be separability with our former thinking. Next, please. We have to list what it would really take to succeed. And I think NEDA started doing that, including what it would cost and how long it would take. It would be good to look at NEDA's plan in terms of the budget. Next, please. Next. For sewerage, this is what NEDA actually has in terms of costings. The action plan number is the specific project, and up to 2037, its indicative cost for expanding the sewerage and sanitation services under the concession agreement for Manila Water is 77 billion. And for Maynilad Water Services is 109 billion. So therefore, that's about 109 plus 77 is nearly 200 billion. And then outside the Metro Manila region, for the entire Manila Bay region, which doesn't yet include the highly urbanized cities that has to, all the highly urbanized cities that have to put in their sewerage systems, there's 9 billion, 11.25 billion, and 4.7 billion for these three projects: non-coastal cities, septage projects in Manila Bay coastal LGUs, and full coverage of septage management for all LGUs outside of Metro Manila covered by water districts and LGUs within the Manila Bay region. So just within the Manila Bay region, it would cost nearly 211 billion pesos till 2037. Next, please. We estimated in 2017 when all of these problems started to crop up what the cost would be. In 2017, it would have been 147 billion, and now only 3 years later, it is 211 billion. Our estimate was just about 188 billion in 5 years, but certainly already much more expensive than in 2017. And this was based on a 3.4 inflation rate and population growth rates as well. Okay. Who is going to spend this money? Section 7 and 8 of the Clean Water Act says that the funds for the construction of facilities may be allotted by the national government through the regular budget, but the local governments are expected to provide the land for the facilities. However, the current plan of the Department of Public Works and Highways requires the local governments to put up 50% of the cost. Hence, they don't have very many takers for this program. And the funding that they have allotted for it keeps shrinking because they don't have takers, because local governments don't have the 50% necessary to set up the septic and sewerage plants and infrastructure. But as you can see from the top, it's the national government through the regular budget that should provide the funds for construction. And later, the LGUs, the local governments, have to pay for the operations of these facilities. Next, please. Well, I just included this slide because the policymakers and the ones budgeting seem to have forgotten that this is really what will make the waste a resource. That we need to go back to the water cycle and ensure that whatever it is we throw out will still be beneficial, and therefore we need to be the ones to place them back into this cycle and make them a usable resource. Next, please. I'd like to end, this is my, I already have a thank you slide, but I'd like to end by saying that we need to determine who will really fund the infrastructure, because right now we are at a stage where the concessionaires in Metro Manila are their contracts are being reviewed, and they haven't heard yet whether their extension will be valid until 2037. But the Supreme Court decisions in the Philippines are clear that these are the concession's responsibility. The Clean Water Act, though, says that it's the national government's budget in its regular budget, but there is a huge difference as to when this money is spent by whichever will spend it. And the longer the delay, the higher the cost, the higher the damage, so the higher the rehabilitation cost as well. And it really needs to be determined that if the government will be spending it, it needs to be in a specific department. And right now, I haven't met anybody in the DPWH who supports putting this in their budget. So I think the only way to make all of this water used by Metro Manila and the highly urbanized cities be usable again and bring it back to the water cycle is for treatment to happen and for there to be a realization of the value of that water if we make it a resource. The value of treated wastewater. I guess that's it. Thank you very much.
Thank you very much, Ms. Ipat Lona. Before we proceed with our next speaker, let's have a quick poll question to our audience. For everyone watching, a poll question will pop up on your screen right now. Would you rather have government spend the money for sewerage infrastructure in its own budget or let private concessionaires build it for profit? You have three choices: private, government, or both. You have 10 seconds to answer. All right. All right. We can see that most of you answered both. Thank you very much for all who voted. We will discuss more about that later during our Q&A session. Our, our next presenter is the founder and inventor of biopipe technology. He began R&D in his second year at Bahçeşehir University with the support of the Turkish government. He was chosen as the best business plan in Tugiyad, this entrepreneur in Turkey by Get Turkey, and most successful young in Turkey in aspects of environmental leadership by JCI TOYP in 2012. He has attended many international programs, including International Visitor Leadership Program by the U.S. Department of State in 2013. Our next speaker, who has won several competitions, is now focused on R&D to continue improving biopipe and expand its use and treating many other types of effluents. Please give us a virtual round of applause to Mr. Enes Kotluka.
Thank you, Sir Onkoy, for the kind introduction. I'm so happy to be here today to discuss methods for a circular economy, a cause that I have been dedicated to for the past 10 years through my invention of biopipe no sludge technology. Today, I'll be talking about the water supply and sanitation situation in the Philippines and the biopipe technology and its application at the Narke Ecological Hotel in Turkey, where the water is being reused to supply an organic form. The Philippines is currently facing a critical point with regards to both the future of the sanitation sector and the levels of groundwater available. Currently, only about 10% of the sewage nationwide is being treated, with the rest being discharged directly to the sea or contaminating underground water supplies through leaking septic tanks or through the dumping of improperly treated sludge. Additionally, because groundwater has become the single greatest source of water supply in the Philippines, with it supplying 50% of the drinking water and 85% of the piped water supply, it is imperative that we look at both issues and how they affect each other. Currently, domestic wastewater is the main contributor of bacterial contamination to the groundwater supplies in the Philippines, contributing to afflictions such as diarrhea, cholera, hepatitis, or other diseases. According to the study done by the VIPA, approximately 58% of groundwater wells represented a high level of coliform bacteria in Philippines. This is by no means just a problem in the Philippines, but also a problem in many countries worldwide, including India, United States, South Africa, and actually many other countries. But nevertheless, it's still a problem that needs to be solved in the Philippines. And these problems worldwide are why I invented the biopipe system, which, as you will see in the following slides, helps address both issues of water loss and issues around improper sewage management. Biopipe headquarters is based in United States, and we have appearance and partnerships in many other countries such as Netherlands, Turkey, United Arab Emirates, Switzerland, Ethiopia, Bangladesh, India, Philippines, and South Africa. So what is BioPipe? BioPipe is the world's first biological wastewater treatment system where the process takes place entirely inside the pipe. As you see on those photos on the right side, you will see PVC pipes where the process is being take place. And you'll see that different number of modules to treat wastewater. So this is a patented system worldwide. It's a highly scalable system, but also the biggest advantage of this system is it doesn't produce any sludge, so that the operation of the plant becomes much more easier. So as you see on the photos that there are different number of modules depending on the size of biopipe. It's a highly scalable system that you can increase the capacity of the system, just like a Lego kind of attach and place system. So where does the technology comes from? Biopipe process actually based on biofilm. It's not an activated sludge process. If you look at the nature, for example, you will see that on the river, you will see green layers of biofilm bacteria on the surfaces of stones at the bottom layer of these rivers. These biofilm bacteria keeps the rivers always clean, and that is happening naturally inside the nature without producing any sludge. So that is called biofilm process in the nature, and biopipe mimics the same process inside the pipes. So all the pipes acts like a small rivers to treat the wastewater without producing any sludge. So if you see the table here, you will see that the growth stage of biopipes, that they are growing in 5 stages, and then they disattach from the surface. So these bacteria and growing stages take place inside the pipes. On the right side, you can check that the full schematics of the system, that the wastewater comes to a wastewater tank, and we have a screen to screen the inorganic solids before coming to the tank, and we have a pump inside this tank to pump the water inside by a pipe. So this is a batch process, it's not a continuous flow. We fill the system, circulate and discharge. We fill, circulate and discharge, and it continues like that during the day. So to do so, we have a circulation pump, we have a discharge pump, and at the end of the process, while discharging the water from biopipe, we have a cartridge filter to capture these disattached biofilm bacteria. And then we have a UV filter, and we have chlorine dosage pump in some cases. So the only maintenance part of the system is this cartridge filter that you need to clean it with clean water to clean out of these disattached biofilm bacteria. So it's a very simple system. It doesn't have many wastewater tanks, many pumps, sludge pumps, and etc. But it's a very simple system that has only one wastewater tank and a filling pump, circulating pump, and discharge pump. And the methodology is very easy. It's just fill, circulate, and discharge. Thanks to biofilm process, there is no odor in the system, and it's a fully automated process. If we compare biopipe with other technologies, you will see that, let's compare with MBR, SBR, and MBBR in this slide. And if we compare in terms of sludge, there is no sludge in biopipe. If we compare in terms of like an operator on the site all the time, biopipe doesn't need any operator on the site because it's a fully automated system that you can control from your mobile phone or your internet. It's very easy to control it. And you don't need to add any chemicals, or you don't need to check anything on the site. So it's a plug and play, fully automated system. Whereas the other technologies, you may need to add some bacteria or some chemicals in the system. If you look at the maintenance frequency, because biopipe doesn't have a lot of electronic equipments, it's just very easy to control. The only maintenance part of the system is the cartridge filter that you need to clean every 3 months. Talking about maintenance frequency, if you look at the operation cost, so as I said, there is no chemical cost or biological bacteria cost on the system. And because we don't use any blower in the system, the electricity consumption is very low. So as the operation cost of the system is very low. if we compare the biopipe system with other systems, for a system 100 cubic meter per day, 100 KLD system, you will see that biopipe has much less footprint than any other system. This is very important, especially for dense cities, for dense countries. The footprint is very little comparing to other technologies. Electricity consumption, because we don't have any blower in the system, we are using Venturi's natural air aeration in the system. The electricity consumption is not very high. And if you compare with other technologies, it is much lower than any other technologies, but at the same time, the efficiency of the system is very high in terms of the treatment efficiency of BOD, COD, total nitrogen, and etc. And because there is no sludge in the system, you get 100% of the water that you supply to the system. This is also very important. If you look at the water quality, the BOD at the end of biopipe system is less than 10, COD is less than 50, ammonia is less than 0.5, phosphorus less than 1, total suspended solids is less than 10, and we can talk about the efficiency is higher than 95%. This is thanks to the design of the system that doesn't produce any sludge and that mimics the same methodology in the nature. And you would see a photo from Maldives, Hilton Hotel, that the incoming water and the effluent water on the right side of this slide. And if you see the other photos, let me give a summarize here. You would see different sizes of modules according to the capacity of the system. In some cases, we can also put biopipe inside containers, or we can place them outside in winter conditions, or we can place them outside again in very hot conditions, hot climate conditions. The only thing that we need to do is to protect it from direct sunlight. So let's look at a case study in Turkey. That's an ecological hotel, and that they are recycling their water, but also all the materials that is being used in this hotel is ecological. And in respect to environment, they started using biopipe. And before biopipe, they didn't have any sewage network connection. So they had a wastewater tank, and they needed this tank to be vacuumed every 2 weeks. And that was a very costly process, and they wanted to reuse their water again for the irrigation for their organic farming. So we save almost more than 7,000 tons of water, and that is reused for irrigation. And the payback period is actually just less than 2 years. It's not an expensive system. If you think that you can treat your wastewater, domestic wastewater, and reuse it for organic farming. So here we have different photos for different projects. What I want to emphasize here is that biopipe is suitable to put on the rooftops or sometimes in the basements. You would see different photos that sometimes a hotel might say that there is no space to put biopipe, but then we can build a structure on the top of a road and then we can put biopipe there, or we can put it on the rooftop. Or even sometimes through a single door, we can install the biopipe inside the basements. So this is also amazing. And if you compare with other technologies on the market, that is just unbelievable that we can fit biopipe and we can design the biopipe for different needs. That's all with my presentation. Thanks for listening.
Thank you so much, Mr. Kotloka. Before we proceed with our next speaker, let us have a quick poll question to our audience. Now, for everyone watching, a poll question will pop up on your screen right now. How do you currently handle sludge? So you have borne it, anaerobic digestion, drying bed, other, or no method of treatment. All right. We can see that most of you answered anaerobic digestion. Thank you very much for all who voted. We will discuss more about that later during our Q&A session. On to our next presenter. He is a lawyer who has had the privilege of sitting on the senior leadership teams of two multi-billion-dollar corporations, Cebu Pacific and Coca-Cola Beverages Philippines Incorporated. During the course of his professional career, he has gained extensive experience in dealing with Philippine regulatory agencies such as the National Telecommunications Commission, Department of Information and Communications Technology, the Bureau of Customs, the Bureau of Internal Revenue, the Civil Aeronautics Board, and the Civil Aeronautics Authority of the Philippines, both as an advocate and a public official. He brings his unique experiences, skill sets, knowledge, and expertise in his current role in Coca-Cola Philippines, in which he is constantly exposed to the intricacies of the country's investment climate, particularly in the Philippine beverage industry environment. Please give a warm virtual welcome to Attorney Juan Lorenzo Tanyada.
Thank you very much for the introduction. Good afternoon, everyone. Good evening, depending on where you are in the world. It's an honor to be here to represent Coca-Cola among such esteemed and very accomplished colleagues. Without further ado, if you don't mind, we could go on with we could proceed with the presentation. So as mentioned earlier, I work with Coca-Cola Beverages Philippines, Inc., with the Corporate and Regulatory Affairs Group. And we basically are in charge of, among others, the sustainability portfolio of Coca-Cola Beverages Philippines, Inc. One of the things that came to mind when we were asked to join today's session was that in March of 2020, the United Nations released a report where it stated that over 95% of wastewater in some least developed countries is released to the environment without treatment. And obviously that brings with it a host of problems. We did a review of a quick survey of what tools are available to us as a country. And we came across the Clean Water Act of 2004, where a stat stood out to us. We found that over 50% of industries nationwide are compliant. So that could be read either positively or negatively, depending on which side of the fence you sit. We also saw that the World Bank basically gave a $275 million facility for Metro Manila to use in its wastewater management project. So much has been done, legislation-wise, probably infrastructure-wise, but obviously there's so much more that needs to be done. As a private corporation, however, we are constrained to do things in the way that we best can as a private enterprise. Foremost among these, of course, is to remain compliant in every jurisdiction where we operate. If you're not aware yet, Coca-Cola beverages have been in the Philippine market for about 108 years already. We've been here since 1912, and obviously we intend to be here for the long haul. We provide over 70,000 Filipinos employment across our value chain. That's inclusive of about 10,000 regular employees, about 6,000 non-corporate resources. And obviously we do have retail partners, suppliers, distribution and sales offices and such. So we could say that, especially with respect to our 19 bottling plants and over 70 distribution centers, that our footprint definitely is on a nationwide basis. Because of that footprint, it becomes important for us to ensure that we address any and all concerns that may be present, particularly on the environmental side. I know that today's focus is on water, but if you will indulge me to share a couple of stats with you, some of them not directly dealing with water. We have well, previously 112, I think now we're at 119% water replenishment level as of 2019, which means we have returned 119% of every drop of water that we have used in our operations for the year 2019. We also use about 65% renewable energy in all our operations. Our trucks are Euro 4 and 5 compliant. 50% of our volume now is utilizing the iconic Coca-Cola glass bottle, the returnable glass bottle, among others. So, since our focus is on water, sustainability is evident in the way we operate. And as mentioned earlier, we want to return every single drop of water we use in our beverages back to the environment, and especially to water poor or constrained, resource constrained communities. And we do this by utilizing sustainable practices in our operations and in our corporate social responsibility efforts. We do have an AGOS program where we make sure that communities that do not have access to clean and potable water do get that access. And we use a number of technologies for them. I think Schumacher would be proud. Schumacher, in his smallest beautiful, would be proud of the technologies that we use, particularly the ramp pump, which basically uses gravity to bring water counterintuitively up to upland communities where before they had no access to clean water. So globally, our total investment in water treatment and such has reached about $1 billion. This has resulted in us being able to return over 170 billion liters of water. That is basically our global figure as far as expenditures is concerned. In the Philippines, we have returned around 23 billion liters of water to the environment. Basically, we've saved that from 2014 to 2020. We've replenished 112% of the water used in beverage production in 2019. This is an example of our plant in CANLUBANG using a wastewater treatment facility that, of course, this technology is quite familiar to everyone. At the end of this process, though, we're very proud to say that the water that comes out of it is enough to support aquatic life. So in our plants, particularly our showcase plants, we do have a fish pond, sometimes a koi pond, that would show basically or evidence the ability of the water that we treat to support aquatic life again. So this is a CANLUBANG plant. A quick stat, it's CANLUBANG plant that has the fastest bottling line of Coca-Cola in the world. It can produce about 81,000 bottles of Coca-Cola per hour. So that's here in the Philippines. Anyway, here's our water efficiency ratio. So you will see that from the years 2014 to 2019, we were able to effect a 31% decrease in our absolute water consumption. And then basically we did this by implementing our top 20 water savings initiatives. So basically right washing at the right time, smart design for optimal bottle washing, and then small steps that bring and derive big gains. So since 2014, more than 20.4 billion liters of wastewater has been recovered, treated, and returned. So as a company, we're quite proud of that, as you can imagine. And as mentioned earlier, because of our corporate social responsibility efforts, we also look forward to watershed protection as part of our environmental efforts. We are a sponsor of the Ipo Watershed Conservation Project. So since 2016, we've done a rehabilitation and information and education campaign directly benefiting over 8,200 residents in the Ipo watershed area here in Bulacan. We also have the AGOS sites where over 236,000 beneficiaries now have access to fresh, clean, potable water. If you can see some of the indigenous people in the background, it was actually their first time to to have in the communities that they lived access to clean water, whereas before they had to literally walk kilometers on end to get water and carry it on their backs on pails. And then you can imagine because of the long trek, they would be losing a lot of water also on the way up. So projects such as these obviously do come as a big relief to them. I've been to a couple of these turnovers and it was very touching to see the reaction of the people who were ultimately benefiting from these projects. Okay, so this is our flagship plant in Santa Rosa. We actually have two beverage manufacturing plants there yesterday in the picture. So what we wanted to show from this slide is that we continue to improve our systems to ensure the efficiency of our water initiatives in manufacturing. But we have encountered two main issues with respect to this. First is the significantly high cost of recovery and treatment of wastewater, as you can imagine. Sometimes it's just really more economically tempting not to just direct your efforts towards, you know, extracting water directly from municipal water supply or direct access to the watershed, but that might not necessarily be the most responsible thing to do. Another issue would be the stringent water quality requirement for our beverages. So we often determine based on water quality the use that the water that we have basically treated will be put to. For example, we could use the water that we have recovered for other purposes, such as probably use in our toilet facilities and our bathrooms, perhaps for cleaning and so forth. But definitely not a single drop of water does and should go to waste in our manufacturing operations. So after COVID, during COVID, even as we look towards the new normal, we remain committed to strengthening our sustainable operational system. And then we will strive to improve our wastewater treatment practices further. We're open to discussing this with our stakeholders, with government, our private sector partners, to ensure that as we operate and continue to operate in the Philippines, Coca-Cola Beverages Philippines Inc. is and will be continue to be perceived as a responsible partner. And I think that should be it for this particular presentation. Thank you everyone for your time and for listening. Maraming salamat po.
Thank you so much, Attorney Tanyada. All right, before we proceed with our next speaker, again, let us have a quick poll question to our audience. For everyone watching, a poll question will pop up on your screen right now. What are the best water practices in your operations? There are four choices. You may start now. We can see the most of you answered water savings initiatives. Thank you very much for all who voted. We will discuss more about that later during our Q&A session. Our fourth and final presenter is the editor-in-chief of the Palgrave Handbook of Climate Resilient Societies, major reference work, and the Palgrave Encyclopedia of Urban and Regional Futures, major reference work, both with Springer Nature. He is the author of a variety of books, including Urban Water Security, The Green Economy, and the Water Energy Nexus, Developing the Circular Water Economy, and the Nature-Based Solutions to 21st Century Challenges, among others. He is also the founder of Our Future Water, research and knowledge partnership with the World Bank's Connect for Climate program to take on climate change, as well as with the unit-hosted Green Growth Knowledge Platform. Give it up for Mr. Robert Breers.
Good morning. Thank you for the kind introduction. Today I'm just going to be speaking about global policies in water reuse and recycling. And it's more just a broad overview of what's going on in the world and, you know, food for thought that could be implemented in the Philippines or the wider region. So it's just more of a survey of what's possible out there. The next slide, please. So in a nutshell, the circular economy, we kind of, you know, understand, you know, it's about reducing, reusing, recycling, recovering, and restoring. In this case, we're talking about reuse and recycle. Now, these terms can change quite a lot in different places in the world. And one of them, for myself, I find the Australian term reuse and recycle to be more easy to understand. So in this context, water reuse systems is without treatment. Rainwater harvesting in houses or buildings, grey water reuse, etc. And when it comes to recycled water or reclaimed water in the US, etc., it's actually about, you know, with treatment. And that's, you know, we all know industrial processes, irrigation and agricultural land, and also blending with surface and groundwater to increase water supply. And then one of the key things about the circular economy that we often forget is that by reducing our water usage, by recycling, by reusing, we actually can restore the natural environment at the same time, leaving enough water for nature itself, aquatic wildlife, habitats, etc., minimum flow levels, environmental flows, etc. So it's a very, you know, on one hand, we're looking at economic efficiency, decoupling economic growth from resource consumption, and also decoupling our economic growth from environmental degradation. So next slide, thank you. So, and this is just a very broad, what's going on out there in the world. You know, some of the most exciting projects that are out there today, and best practices can be taken away. They can be implemented in any country, any context. So the first one here, we have the Hamburg water cycle. So Hamburg Water in Germany is creating a residential development with 2,000 residents and 35 acres. Now, what the Hamburg water cycle is doing is inside the houses itself, black water is separated from grey water. They actually have vacuum toilets that almost use no water. So the black water is highly concentrated, easy to be then processed and with lower energy costs. The rainwater is collected separately, and grey water is also collected separately for flushing toilets and also putting back water to nature itself. And this is part of a wider Jenfouder Au project, which is actually on a former military barracks in Hamburg. So it's about, you know, creating a new housing development, but also implementing 21st century solutions instead of just, you know, status quo, same old, same old. This was about creating a water cycle of the future as a demonstration project that inspires people in Hamburg or the wider region in Germany and Europe, or etc. Anywhere in the world, this is possible. So next slide, thank you. And then I see some questions about, you know, Q&As about on-site water reuse. Now, what New York City is doing is that they're providing grants to commercial property owners to install on-site water reuse systems. Now, one of the innovative things that they're doing here is that they're actually saying these grants can be available for the individual building, but also developers can actually create a district level plan of implementing on-site water reuse systems that involve multiple buildings. So that pulls resources, it pulls knowledge. Also, you don't have to replicate the same thing, you know, reinventing the wheel every time for every building. So the grants are there, and with the regulations, of course, the systems can only be used for flushing toilets and urinals, cooling tower makeup, and subsurface irrigation and drip irrigation. And then when we head off to Europe here, which is really interesting, we have this tailored industrial water example. And, you know, Belgium's De Water Group actually provides tailored industrial recycled water for its customers. So first, the water utility will actually go to the customer and look at all the internal water streams, sources of available water, including wastewater, reusable processed water, and think about opportunities available. And then instead of telling the client, sure, here's some grant funding or whatever, you know, go and build it, it's not our problem. actually they sit down and on a design, build, finance, operate contract, the actual water utility itself will actually build the system for the client as well. So that's kind of like a win-win. I guess it's a public-private partnership. And that's another type of, solution that's available out there. Next slide, please. And then heading off to California, we see a lot of recycled water being used for agricultural production. In this context, the South Sacramento County Agriculture and Habitat Lands Recycled Water Program, a very long name, is providing recycled water for agricultural uses. And, at the same time, while providing irrigation water, the recycled water is actually replenishing surface and groundwater supplies. And this is one of the actual objectives of a program, is to ensure that habitats actually have wildlife actually has a chance of surviving. So this program has dual purposes. On one hand, enabling agriculture production, etc., but also enabling the nature to have, instead of agriculture taking all the water and leaving nothing for nature, this is actually trying to find a solution here. And the next one, please. And when similar to Belgium's, fit for tailored industrial water, what the Queensland water utilities have done is they've created a fit-for-purpose recycling program, and that offers different classes of water, different classes of qualities of recycled water. So basically, if you want high-quality recycled water, you pay more for it. If you want low-quality recycled water, you pay less for it. Very simple. It's based on a per kilolitre charge, with the price increasing with quality itself. And obviously it can't be used for drinking water, and it can only be used for non-food crops, forestry plantations, and below ground irrigation, and above ground food crops. But I think this is quite a neat way to show, how can you create different revenue streams for a utility? How can you, promote water scarcity? How can you factor in high energy costs? You charge more for it. The people want it, they pay for it. Next slide. And then we talk about, of course, the neighbours, Singapore. What they've got is a new water. It treats, used industrial water into ultra clean, high grade reclaimed water. And use industrial aircon cooling purposes, wafer fabrication plants. And one of the things is it's delivered on tap. They have they've gone and created underground systems, deep tunnel systems that transport all this water around the city. But also, interesting enough, is during the dry periods, the new water can actually be blended with raw water in the reservoirs to supplement the supplies. And then obviously it goes through its treatment processes, goes to wastewater treatment, it eventually goes to all the different treatment processes to finally becoming potable water for the consumers. And that's only done in an emergency situation. Now it's interesting because this water is actually meant to be making up to about 60% of the demand for industrial water in the next coming decades. And so basically, what overall, a very short, snappy, around the world in a few minutes here, I'm kind of coming in to say, what is possible, what is out there. And I suppose what I'm really saying is that rather than implementing 20th century, old technologies, a lot of countries have a chance to just leapfrog technologies and implement systems and move forward and take the technology and even be higher than, when you've got something to start from scratch, you can implement anything you want. When you've got, old legacy systems, it's very hard to retrofit these things. So my hope for today is that people will take this away and think, wow, this is what's going on in this country, this is going on in that country. Let's try to implement this in our home, or even export it to another regional location. So on that note, I hope you've, feel free to connect with me on LinkedIn or join my groups, Our Future Water, and continue the discussion. Thank you so much for hosting me. Thank you.
Thank you so much, Mr. Robert Beers. Again, before we proceed with our next segment, let's have a quick poll question to our audience. Now, for everyone watching, a poll question will pop up on your screen right now. What are the main barriers to water reuse and recycling initiatives? You have regulations, financial, community perception, and over health concern. You may answer now. Okay, all right. We can see that most of you answered financial, which is 60%. Thank you very much for all who voted. Thank you. Now, this is the moment everyone has been waiting for, the question and answer portion. For all our audience, please type in your questions at the Q&A box that you may see on your screen. We will select topic-related questions and have it answered by our speakers. So please keep them coming. All right, well, some of you are already sending some questions. Let's answer some questions which was sent to us before we start today's webinar. All right. Good afternoon to all, everyone. We have the first three questions here that coming from, the two are coming from Jollibee Services, and the other one, Ripcon Engineering Services. They are actually related questions. First, on Jollibee, how to make wastewater treatment economical. And another one from Jollibee, sustainable water retreatment options that would fit restaurant setups with limited location and maximum efficiency for the NR standards. This is about the, in terms of limited, maybe limited space, putting up a wastewater treatment or sewage treatment plant. Now the third question is, you take on wastewater treatment regulations and how this impacts future projects during and post-COVID, the pandemic period. I would like to refer this question to our Miss Ipat Lona, please.
Yes, well, there are three questions, but they're interrelated. First, I'd like to say that the way, of course, to economize is not to violate, because violations require ever-increasing penalties. If there is a difficulty in compliance, of course, they can again go to the DNR to make their case to say that there is too much of a difficulty in compliance space-wise. But the real issue that is that EMD responds to is that if some can comply, then there is no excuse for the rest. So I think we just need to keep upgrading the quality of the technical responses, so that as the policy improves, which we hope it can in the next few years, specifically the standards in 2016, then hopefully compliance will be achieved by most companies. See, the enforcement cost is very high. So actually, the human resources are limited and cannot visit all dischargers, and all dischargers are required to comply. So that makes it uneconomical for both government and for, I guess, the private sector. So maybe we should revisit sections 25 and 26 of the Clean Water Act, which provides for rewards and incentives for better wastewater treatment. That can probably be a good way to incentivize wastewater management.
Thank you, Ms. Luna.
Not just a question policy-wise, but I think they're also looking for technical responses to that question. So one of the possibilities is do technologies like biopipe, for example, allow spreading on, for example, the floor, under the floor. Is that a possibility, Mr. Ennis, for example?
Thank you, Ms. Lona. You have another question from Thomas Matison. One of the greatest challenges is funding the wastewater infrastructure and balancing the cost to the end user. How can the DNR help drive a step change in the public's mindset and understanding of the importance of this program?
Yes, as I said, there are incentives in the Clean Water Act. There are rewards and incentives for those that manage their wastewater stream. Section 25 in particular and Section 26 requires that the DNR create a committee to determine how to give these rewards, and also an incentive scheme for LGUs, water districts, and enterprises. I think at this point, it's not incentivized because the NSSMP of the DPWH requires a 50% counterpart for the LGU, and that's not even available for the water district. But I think there may be ways around that for the LGU to build it in the name of the water district. NEDA would probably be able to answer that better. At the same time, other incentive schemes like tax and duty exemptions on imported capital equipment, tax credit on domestic capital equipment, tax and duty exemptions on donations, legacies, and gifts. Those are available for any LGU water district, enterprise, or even private entities that manage their wastewater or undertake effective water quality management, or even actively participate in any program geared towards the promotion of wastewater management. So I think it's just I think the Section 25 and 26 can be requested from EMB, the Environmental Management Bureau, if these are already available. Of course, they're a matter of right because the law already says that, but the mechanism and the machinery for giving those rewards and incentives have to be hammered out.
Thank you, Ms. Luna. We have another question here. Before the webinar, start with the webinar. From the Water Industries Network Corporation, what would be the cost to convert wastewater for reuse, and what would be the process? I have to, may I refer this question to Attorney Juan Lorenzo Tanyada? Please, Attorney.
Good afternoon again, everyone. So globally, as a system, we spent around 1 billion USD to have our wastewater facilities in place. We probably will be able to extract the cost allocated for the Philippines by basically considering that we returned 23 billion liters of water from the 170 billion that the Coca-Cola system returned to the environment globally. So I would say approximately 15% of that, if we're just going to do a rough estimate. As far as processes go, I think I will have to defer to a technical person as I'm not an engineer and I'm only a lawyer. Thank you.
Okay, if you may do so, Attorney, if you have a technical person beside you, or explain further on the process.
Yeah, I think there can be someone from the panel who will be able to explain.
Okay.
Thank you.
Yes. Maybe it could be also, there are some related questions with regards to the process, Attorney. So we'll proceed with another question. This question was sent by Rockwell Land Corporation. Is it possible to have the treated wastewater via sewage treatment plant immediately be reused as potable or non-potable water? I may answer this question. It is actually possible to reuse as non-potable water, but not immediately to reuse as potable water. Now, for potable water,
Hi everyone, good afternoon. I'm Al from Informa Market. It seems like Sir Rico Ongkoy has some connection problems. So while waiting for Sir Rico to get back in the webinar, we will read some questions and throw it away to our speakers. Okay. We actually have another question for Attorney Miss Ipat. Um, can there be an incentive program if a company really target and attain a zero discharge on their wastewater treatment facility and not just being compliant? This one's from Sir Cesar Cruz.
Yes, thank you. Again, maybe we should ask the Environmental Management Bureau. I'm not updated with what they have done, but the Clean Water Act Section 25 and 26 requires that the DNR make up a rewards and incentives program. Oh, am I choppy?
No, ma'am, please continue.
Sorry, I thought I was choppy. Yes, maybe they should ask the Environmental Management Bureau on Section 25 and 26 because the DNR is required to have a rewards and incentives program. I'm not sure what the status of that is and how the EMB has rolled that out, but it is a requirement under the Clean Water Act. And it's probably difficult for the EMB to do so because there are it's very difficult for them to sweep up the whole universe of dischargers to get compliance. So rewards and incentives for a few when there's still a lot of dischargers non-compliant would probably seem to be a little off, but that's required under the law. So Section 25 and 26 is what people should look at to see whether they can get incentives and rewards, particularly 26, Section 26, which has a lot of tax exemptions and a donor's tax and domestic capital cost exemptions from taxes.
Thank you, Ms. Ipat. We have here another questions. Actually, you guys have been answering questions because we have a lot of questions coming in. You guys have been answering to them via chat. So let's have another. There are a lot of questions for Biopipe. So, Sir Ines, I think you could answer one of the questions here. Um, Regarding the cost, is it within the reach of the people? Your product, sir.
Yes, it is. Actually, let me try to answer, like, if you let me, like, try to answer all the questions in a very short paragraph or something like
Yeah,
that.
sure.
Maybe it will be more helpful and to use our time more efficiently.
Definitely.
So a lot of questions asked if we have any systems in Philippines. Not yet. We have systems more than 15 countries, but we are planning a system in the Philippines in the next following months. It's a little bit delayed because of the current situation. Is Biopipe capable of domestic or industrial wastewater? Biopipe is capable of domestic wastewater. It's not for industrial wastewater. For industrial wastewater, we have other solutions. And saying domestic wastewater, that means the BOD is maximum 800 and COD is maximum 1000. And Biopipe is capable of treating just black water or gray water or black water plus gray water combined together. So lifetime of Biopipe is more than 30 years. And the maintenance frequency, we don't need to do any maintenance on the pipes side. The pumps that we are using, that they have their own warranties and guarantees. The only maintenance that we do is the cartridge filter, where we clear the disattached biofilm bacteria. That is every 3 months. And it's not changing or replacing the filter, but it's just cleaning the filter, which is very easily done on the site. Is the water after Biopipe is potable or not? It's not potable, but you may use reverse osmosis or ultrafiltration after Biopipe to make it potable. Although the parameters that we have is much better than potable water in many countries, still there's a psychological aspect of it, and there are some health concerns around it. So it's better to always have a reverse osmosis after Biopipe if you want to drink this water. Do we need to recharge the bacteria? No, we don't need to recharge the bacteria. Once you put the bacteria, that lives there for a very long time. full capability of maintenance with our partners in Philippines. So we don't have any system yet in Philippines, but we have the partners in Philippines, and we have the full capability of maintenance and installation in Philippines in everywhere. Those are the questions that I picked like in very short time. If you have time, I can answer
Yep.
more.
Yeah. Yeah. Actually, definitely, Sir Ines. You can for our attendees who are watching right now, you can actually get in touch directly to the Biopipe team because later we will share their contact details. I know their product or their technology is really groundbreaking. You know, for especially here in our country. So you guys could get in touch with them directly to get to know more about their services. Okay, now we have Engineer Rico Oncoy back with us. Engineer, can you hear us?
Yes, yes. Sorry for that. There
It's
was
fine. No worries, sir. So we
there were
just
some
asked.
there were some glitches in my in
Yeah,
our
internet. Yeah,
internet.
actually,
Sorry for
sir,
that.
we just asked Sir Ines about the information about their products and services. And before I pass you, I pass the moderation again to you. There is another question from Miss Bernadette Estioco. This one's for Attorney Tanyada, how were you able to achieve 112% replenishment? Does it mean you have zero discharge?
Yeah, so thank you for the question, Mrs. Yoko. Good afternoon again. No, it doesn't mean that we have zero discharge. It basically just means that the water that we do discharge is reprocessed so that we will be able to use it again. As you can see, we do have, well, as you may have seen in our presentation, we do have in our plants particular ways of making sure that the water that we use is reprocessed and able again for us to be used either for our office facilities or even in our actual manufacturing operations, depending on the quality of the water. As it ends the cycle, as we mentioned earlier, we're very proud that we are able to reuse that water and make it good enough to support aquatic life. You might be asking, how is it that we're able to do in excess of 100%? The reason we see that we have returned 112 or 190% back to the environment is because not only do we reprocess the water that we have used in our manufacturing operations, we've also been able to take water back and allow other communities which do not have access to clean water to have access in turn. So basically, we're giving water to them. I hope that answers your question somehow. And I can be more clear if you wanted to ask it with more, with more detail. Salamat.
Thank you, Attorney Tanyada. Now we have another question here from Mr. Albert Castro. How can you address the limited space for sewage treatment plant among existing structures so they can comply with the government requirements? Maybe yes, look, maybe this in terms of globally uh, scenario, or can we refer this question to Mr. Robert Breers?
Hi. First, I've been seeing around the world a lot of retrofits of sewage treatment plants and able to recycle water, and casting a little wide, I've seen communities in California, and there's also recently a community in Queensland, Australia, do the same thing. Very small communities, only 30,000 people, and they managed to retrofit their sewage treatment plant to also recycle water as well. So in that sense, limited space, it shouldn't be a problem. From the policy side, makes sense. From the fiscal side, it makes sense. Saving financial instead of having to rebuild and take costly land or take coastal zones for desalination plants. Use what you've got, I believe. Thank you.
I have
Right.
also some comment on that. So this is a problem, especially in big cities and dense cities in Asia and Africa, also in Turkey, that there is a very limited footprint, and the city is already crowded. Sewage infrastructure is not there, and how to put a small system there. And before, like 100 years ago, maybe the governments were trying to build sewage networks under the cities and to build a very big wastewater treatment plants for the cities. But now actually it's changing, and decentralized wastewater treatment solutions are available on the market. And as for the biopipe technology, the system that we have is the solution for decentralized wastewater treatment plants, that you can put any system under your basement or on the rooftop of your building or anywhere in between roads, because we can design the pipes as per the request, that we can make them wide and long, or maybe we can make them not long, but we can fit them in a very narrow places. So by saying that, biopipe offers a solution in there for small footprint areas, as for the technology part of it, technical part of it. Thank you.
Okay, thank you, Mr. Kotloka. We have, I think, this is the last question now from Brickley Corporation. What is the best wastewater treatment system or solution for municipal use? May I refer this question to both for Mr. Robert Breers and Mr. Kotloka.
I personally think that the best, solutions like biopipe suggests the decentralized solutions. They have to happen in households and buildings, individual and hotels, supermarkets, football stadiums. This is the way of the future, and also you can capture the rainfall, you can reuse stormwater, harvest it, replenish groundwater supplies, use those supplies for your own use as well. This has to be the future of circular economy at the local level, decentralized, also gives chance to restore the natural environment in the neighborhood and the community that you live in as well. That's my take on this. Thank you.
Okay, thank you so much. So the last almost 30 minutes, we have discussed our questions and answers from regulation for the actual technology, and from the manufacturing good practices, and also from in terms of global situation. Now, thank you for all speakers and participants. Now, as we have mentioned earlier, once this webinar ends, you will be redirected to a survey page on your web browser that, once you have finished answering all, will allow you to download the slides of our presenters for today. You may also go to website link or scan the QR code that are flashing on your screen right now. On behalf of the speakers, Biopipe Global, WaterPhilippines, the Philippine Water Works Association, and Informal Markets, I am Engineer Rico Ongkoy. Thank you very much, and see you again at the next webinar by WaterPhilippines. Thank you.